Plant design. In this segment, we are going to discuss about selection and considerations of different plant equipment. So an anaerobic digestion plant can be divided into the following section: feedstock receiving and handling, anaerobic digestion tanks, where the anaerobic digestion itself takes place, biogas capture, cleaning and upgrade, if you desire to upgrade that biogas, and then digestate handling and resource recovery if that is desired. Equipment selection, design and layout consideration for each of these sections will be discussed in the following slides. Let's start with feedstock receiving. While designing a receiving station, we need to consider about feedstocks. So are there multiple feedstocks? Then we may need to have multiple storage area. Usually for liquids like fog and wastewater sludge, tanks are used. And for solid and semi-solid waste like food waste, there are concrete basin and stainless steel pits. So basin can be covered or the pit can be covered or uncovered based on the odor situation. And then we have to consider how the feedstock will be received at the plant. Usually a truck or tanker bring the waste to the plant. So we need to have truck or tanker unloading station. And there should be appropriate pump and pump connection for transferring the liquid from the tanker to the storage tank. Usually it is preferred to have inline grinder to prevent debris, rags and large grease balls or other larger waste from clogging the pumps and piping. And we also have to consider the temperature of the feedstock because some feeds needs heating like fog. So there should be heating provision of the storage tank. Then we have to think about the pretreatment of the feedstocks, and that will depend on the type and characteristics of the feedstock. Like contaminated food waste from supermarkets are usually need to depackaging, plastic and metal removal, then macerated to slurry. That slurry is then stored to the tank and then pumped to the digester. And also we have to think how we are going to transfer the feedstock from the feedstock storage tank to the digester. We have to think what will be more convenient or suitable or economical. It's like to have multiple transfer pump and send the feedstock directly to the digester, or to have a mixing tank for mixing different feedstock and then transfer it to the digester. And also we have to consider about odor control, and that will depend on the type of feedstocks and the odor situation. Usually the storage tank vents are sent to biofilter or activated carbon filter to take care of that. This is to give you an idea. This is how a fog or high strength waste receiving facility look like. We can see that there are 3 storage tanks, and then there are pumps dedicated to them, and also the vent from those tanks are bring to a biofilter to take care of that. And there is another feedstock receiving station. We can see a tanker doing the waste here, and then there are transfer pump to transfer the waste from the tanker to the storage tank. Let's start with anaerobic digestion tank and tank mixing. The most common shape for anaerobic digestion tank is cylindrical one. Especially for United States, it is shallow and cylindrical type. The egg-shaped digester is more recent one, mostly adopted in Germany and growing popularity in the United States. The advantages and disadvantages of these both shapes are going to be discussed in the next slide. For conventional cylindrical shaped digester tank, the advantages are it can store larger volume of gas, it can be covered with gas holding cover, and it's a low profile structure and it has a lower construction cost. The disadvantages are inefficient mixing and data spaces, grit accumulation due to inefficient mixing, and more prone to foam and scum accumulation and more downtime. For egg-shaped digester tanks, the advantages are higher mixing efficiency due to shape, a smaller footprint and less land area requirement, lower foam and scum formation, and that's led to lower operating and maintenance cost. The disadvantages are very little gas storage volume and high profile structure and higher construction cost. Here is a comparison between conventional cylindrical shape and egg-shaped digester tanks. For gas storing capacity, cylindrical shape can store a larger volume of gas because it can be covered with gas holding cover. For egg shape, it has very little gas storage volume and it may require external gas storage facility. Regarding constructability, cylindrical shaped digester is a low profile structure and that leads to lower construction cost. But for egg shape, it's a high profile structure and require higher construction cost. Regarding tank mixing, cylindrical shape reactor cause inefficient mixing and dead spaces. For egg shaped digester, egg shape promotes higher mixing efficiency. Regarding operation and maintenance, cylindrical shaped one is more prone to foam and scum accumulation and more downtime. That leads to more downtime. But for egg shaped one, lower foam and scum formation leads to lower operating and maintenance cost. Also for the cylindrical shape one, grit accumulation happens due to poor mixing, but for egg shaped one, there is minimum grit accumulation. Let's move to digester mixing systems. Digester mixing system can be three different types: gas injection mixing, mechanical mixing, and pump mixing. Gas injection mixing is done by releasing gas bubbles that rise up, moving, carrying, and mixing the digester content. That itself can be divided into two categories: the unconfined type that collect gas from the top, compress and then discharge back through bottom diffuser or cover mounted lances, and then confined type that collect gas from the top, compress and then discharge back through confined tubes. Here's a picture of the gas injection mixing. And there is mechanical mixing that is done by low-speed turbine or mechanical mixers. So low-speed turbines are usually cover-mounted motor with turbine impeller at different depths of the tank. And low-speed mixtures are usually one cover-mounted mixture, one big one that cover the whole tank. And there's an innovative one that's known as linear motion mixer. That's a ring-shaped disc that's oscillated up and down, mixing the entire digester content. And there's the image for that one. Then there is pump mixing. That is done by recirculation pump with external piping. Usually propeller type pumps mounted on internal or external draft tubes. And there is an increased trend of using pump mixing in recent digesters. Advantages and disadvantages of different types of mixing. Gas injection. Advantages. Cover-mounted lances are effective against scum buildups. Bottom diffuser provide better movement of bottom deposits, and gas piston type provide good mixing efficiency. Disadvantages. Poor mixing and higher maintenance issues, corrosion of piping, plugging of lances and diffusers, scum and foam formation, etc. High maintenance requirement for compressor and require digester dewatering for maintenance if not cover mounted. Mechanical mixing. Usually good mixing efficiency, can break up scum layer, and equipment maintenance is possible without taking the digester out of service. Disadvantages. wire of impeller and shaft, require oversized gearboxes, and may require maintenance platform and equipment hoist. Pump mixing advantages. Good mixing control. Scum layer and sludge deposit can be recirculated. Pumps are easier to maintain than compressor. Disadvantages. Plugging and impeller wear of pumps, high electrical consumption, and higher mixing may contribute to foaming. This table shows some typical mixing design parameters, such as unit power, applicable to mechanical systems, and typical values are 0.025 to 0.04 horsepower per 10 to the power 3 gallon of digester volume, or 0.005 to 0.008 kilowatt per meter cube of digester volume. Velocity gradient or G values applicable to all, and the typical value is 50 to 80 per second. And then turnover time of tank contents applicable to confined gas mixing and mechanical systems, and the typical values are 20 to 30 minutes. Gas collection and handling equipment. In typical cylindrical digester, gas is collected under the cover of the digester. There are three different types of digester covers available. One is fixed cover. It is fixed with a free space between the roof and the digester liquid surface. Gas, not air, should be drawn when the liquid volume change. It is low in cost but has limited gas storage capacity. Produced gas should be stored externally in a gas holding tank with a floating cover or in a pressured vessel with a gas compressor. And then comes floating cover. It floats on the liquid surface of the digester. It changes levels and allows volume of the digester to change with varying content level. It can provide good scum suppression and insulation, but cannot store much gas and very costly. So this is the image of a fixed cover digester, and this is the image of floating cover digester. We can see that this floating cover change the volume of the digester with different digester content, and this cover is fixed in a fixed space on top of the digester. Membrane cover. It consists of two layers of gas membranes and a central gas dome support structure. An air blower system provides pressurized air between the two membranes, and only the gas membrane and central gas dome are in contact with the digester contents. This is an image of gas membrane cover, and these are different components of a gas membrane cover system. Other gas handling and safety equipment. Gas safety equipment. Pressure relief valves, vacuum relief valves, flame traps, and automatic safety shut-off valves should be installed, and they should also be protected from freezing. Gas monitoring. There should be a gas monitoring system with sensors installed in the gas collection gallery and in boiler or control rooms. Gas piping and condensate. Gas piping should have a condensation trap installed in a location that is not subjected to freezing. Gas supply lines to the boiler should be equipped with suitable flame traps. Other gas handling and safety equipments include waste gas flare. The biogas plant should be equipped with a waste gas flare to flare excess gas produced. Then gas utilizing boiler should be located in separate well-ventilated rooms. And there should be gas meters to measure the amount of gas produced, and the meter must be specifically designed for corrosive and dirty gases. Building and process equipment should comply with the electrical classification guidelines such as NFPA 820. Gas cleaning and upgrade equipment will be discussed in a separate lesson. Let's move to digested handling and treatment. So digested in general is very wet. Usually water content is greater than 95%. So it requires sufficient storage before further treatment, disposal, and resource recovery. And it can be done by using digested holding tanks or lagoons or ponds. Sometimes to reduce storage, handling and transportation cost, different solid-liquid separation, thickening and dewatering approaches can be adopted. And when solid and liquid part are separated, there can be separate treatment of solid portion before disposal and or resource recovery, and there can be separate treatment of liquid portion before disposal or resource recovery. Solid-liquid separation or dewatering can be done by the following technologies like gravity dewatering, mechanical dewatering with polymer addition, electro dewatering and pressure, solar drying and thermal drying. The following dewatering equipment and systems are available commercially, such as solid bolt centrifuge, belt filter press, plate filter press, rotary press, screw press, sludge drying beds and lagoons. Once the solid and liquid portions are separated, there can be further treatments for both the portions. Further treatment of solid portion include further drying to produce granular fertilizer, pelletizing, or composting in windrows or in piles. Treatments of liquid portion include sent to wastewater treatment plant or treat it separately as high-strength wastewater in MBR, SBR, or with other suitable treatment technologies based on its characteristics or if there are further resource recovery options. There are other considerations while designing a biogas plant as well. One of them is to get the idea of how economical the plant is going to be, and that can be get from the projected plant income and cost. So plant capital and operating cost should be calculated, and then possible grant and financing options should also be explored. And once those data are there, then comparing income or benefit from the plant, possible income and benefit from the plant should be compared with the cost of running the plant, and that will give the idea about the overall plant economy or also the period, the return of investment period on the plant. Plant location is also very important. So it should be keeping in mind that transportation and waste receiving and disposal should be convenient both from and to the plant. And also there should be heat and electricity demand and usage in the surrounding community so that the excess produced in the plant can be sold there. Also, the location should be aesthetically acceptable to the surrounding community. And local regulation and laws should also be followed, because if the local regulation and laws does not approve, then the plant cannot be constructed there. That's why applicable planning and construction laws, waste permit, and all those supplementary laws should be discussed before choosing a location. For suitable major and auxiliary equipment and complete plant layout and design, similar reference plants should be contacted or can be considered, and then different manufacturer or equipment suppliers can be compared for their warranties, after sale care, training and maintenance, etc. And then electrical standard and connection should also be considered to find out whether they are compatible to the overall plant. Civil engineering construction of tanks and buildings plays are in an important role because they are a big part or major part of the plant. Then there are considerations for plant operation and maintenance, like who will run the plant. So what is the operator hours needed and how many operators we need to fulfill that work. And also running hour and associated cost for each process equipment. And then we also need data collection and monitoring for the performance of those process equipment and the overall plant. And there should be a safety planning and measurement for the overall plant safety. So Sustainable Energy Authority of Ireland has developed a checklist for developing an AD project, and that can download from the following link. So with this slide, I'll close this segment, and our next segment will be anaerobic digestion types.